We just started on number 28. So let's start with number 28. So what do we have in this question type or these types of questions? What we have is you will be given a projectile. You might be given its initial velocity and the projection angle. And then you might be asked to find out where that projectile will hit a given geometry. Say, for example, a kind of a ladder which might be at an incline from the ground. So let's look at this scenario B. So in this scenario, by the way, is the diagram visible? If it is, then I don't need to zoom in. But if it is not visible, let me know. So let me look at this scenario. Let's say there is a ladder with the base at coordinate x0, 0 and at an angle alpha. And you are given initial velocity u and the projection angle theta. And you might be asked to find out the coordinates of this point. Okay. So essentially, what we are trying to find out is the intersection point of these two curves. What two curves? The first one is the parabolic path followed by the projectile, and then the other one is the straight line. So what is the equation of the trajectory? So y is equals to x tan theta minus, what is it, beta? Gx squared by 2u squared cos squared theta. Is this what it is? How do you find the equation of the trajectory? Let's go back to the basics. So x is equals to u cos theta t. Y is equals to u sine theta t minus half g t squared. So from here, if you take t as x by u cos theta, so you will get y as x tan theta minus g by 2 x squared by u squared cos squared theta. Correct, no, beta? Okay. Now let's write down the equation for this straight line. So what is the equation? If you are given the slope and you are given one of the points on the line, then how do we find the equation of the line? Well, you can use y minus y0 upon x minus x0 as m, or the slope that is tangent alpha. What is y0 and x0? x0 we know, y0 is 0. So I'm going to write y upon x minus x0 is equals to tangent alpha. So y is equals to x tan alpha minus x0 tan alpha. Now what do we have? We have two equations. And how many unknowns are there? So the unknowns are x and y. And we need to find out these two coordinates. Okay. Better just give me a quick second. नीचे जा अभी नहीं मेरे बेटा, अभी नहीं, क्लास लेट हो रही है, बिल्कुल भी शोर, बिल्कुल. Okay, so continuing here. Okay, so carrying on, we have these two equations in y and x, and we want to find out the point of intersection. So let's say the point of intersection is x1, y1. So the x1, y1 should satisfy both these equations. That is the equation of the parabola traced by the projectile and the equation of the line. So if we put that in there, so you will get two equations in two unknowns x1, y1, and you should be able to solve for x1, y1. Is the approach clear? How do we proceed? on such type of questions? I need a quick affirmation and then we'll move on.
Yes.
Okay. This seems like an older question, so let's straight away jump into anti-abhyas question, and we'll do perhaps one or two questions. Let's see if we can find a good one. Let's do this one. So what do we have? Let me read through it. Stone is projected from the ground with a velocity of 50 meter per second at an angle of 30 degrees with the horizontal, and it crosses a wall after 3 seconds. How far beyond the wall the stone will strike the ground? How far beyond the wall? The height of the wall is not given, right? So while you guys are trying to solve it, let me just double check and see if there is any issue with the question here. No, the height of the wall is not given. So, aha. So, by the way, it's not trying, we're not being asked to find out the entire range. We are only being asked to find out the distance from the wall. Good. That's a good question. While you guys are trying to solve it, I'm going to just scribble. So you guys don't need to look at the screen to carry on.
So 86.5.
How much is it, Vidal?
So 86.5.
86.5.
Yes, sir.
Sir, I had one doubt.
Yes, Peter?
Sir, why are we finding the edge?
We don't need
Yeah.
to be honest.
So why can't we just find, because time is given, we can find the range till the wall and total range and then just subtract it.
Exactly.
Okay.
Exactly. So you can find the total range and then subtract the distance it travels, that is u cos 30 into time t, right? So sorry, I'm just playing around here, but make sure that I write it down. So R is simply u squared, that is 50 square, sine of 2 theta, that is sine of 60, divided by g. And what is this distance? Let's call it x. X is equals to 50 cos 30 into time, which is 3 seconds. So that is 150 root 3 by 2. I think that's what you guys are saying, correct? So the difference of the two, r minus x, is 100 root 3 by 2 or 50 root 3. So 50 into 1.732, 85.6. Or did I, sorry, 86.5. Okay, let's see if there is anything interesting. Something with the, it says two tall buildings are 40 meters apart. With what speed must a ball be thrown horizontally from a window 145 meters above the ground in one building so that it will enter a window 22.5 meters above from the ground in the other? Let's quickly do this one and then we'll move on to the next question time. Yes, Peter?
Sir, approx 8 hour.
Approximately 8.
हाँ सर approximately 8 hour.
Approximately 8 hour. Okay. Next question type पे चलते हैं. So we'll move on to the next form. Now let's talk average velocity during a part of the flight. So we'll look at two scenarios. We'll look at the during a symmetric part of flight, and we'll look at average velocity during a asymmetric part of flight. So let me ask you guys a question. For a symmetric part of, let's say somebody says, what is the average velocity between the point of the launch and the point of the landing? Between the point of the launch, what will be the average velocity? So let's assume that this is x, this is y, origin being at the, not that it matters. But what would you say is the average velocity, Vida?
So total distance in x by total time.
Okay, and what will that be? Ruchika, what will that be, Vida? What will be V average?
Horizontal. Sir, will it be V cos theta?
Simply U cos theta, right?
Yes.
So net displacement is the final position minus the initial position. So that is simply your range. What is range? U cos theta into the time of flight, and I'm going to call it I cap, right? If the displacement is from A to B, this is your displacement, divided by the time, which is the time of flight. So it's simply U cos theta I. Let's say instead of this, if somebody were to say that from a height h, it crosses another height, what is the average velocity over this duration? What will that be, Peter? So what will be the average velocity between C and D?
So u into cos of whatever angle is there, alpha.
So let's say this is V and this is alpha. So same logic, if you were to follow, you will get it as V cos alpha. I cap.
Yes, sir.
And we know V cos alpha is still same as the U cos theta. So for any symmetric part of light, so what do we mean by symmetric? Symmetric means if you draw a line bisecting or cutting through the parabolic path in half, then you have to have the launch point and the initial and final point at the same vertical height, right? That's calling it the symmetric part of the light. So U cos theta, we are clear, no, beta? Yes, no? Now let's find out the average velocity between these 2 points when, let's say, that the particle between the launch point, let's call it A, and the maximum height. So what will be the average velocity? And give it to me in the vector form, beta. The vertically upward direction, we have y-axis. Along the horizontal, we have the x-axis. The initial velocity is u. Second is theta. So what is the average velocity between A and B? What will be the average velocity between A and B being at the maximum height, A being at the launch point. What is it? Yes. Were you guys able to make some progress there?
So 2 cos theta by 2 I cap. So not 2 cos theta, u cos theta by 2 I cap and u sin theta by 2 j cap.
That is correct. Ruchika beta, is this what you have as well?
Yes, sir.
Okay. Have you guys solved this problem? This is a JEE Advanced 2019 problem. Let me quickly check. What is the other one that we have? It's a repeat. Gone wrong here. Same question appearing twice. So let's go ahead and would you guys want to give it a try? Maybe at home. Don't leave it behind. Okay, please do solve it. It's a good question. So let's read through the question, then you can solve it. A ball is thrown from the ground at an angle theta with the horizontal and with an initial speed u0. The resulting projectile motion, the magnitude of average velocity of the ball up to the when it hits the ground for the first time is v1. That means u0 cos theta, right? So v1 is u0 cos theta. After hitting the ground, the ball rebounds at the same angle theta, but with a reduced speed of u0 by a. Its motion continues for a long time as shown in the figure. If the magnitude of the average velocity of the ball for the entire duration of motion is 0.8 v1, the value of alpha. This u0 by alpha, not u0 by a. Correction there, it should u 0 by alpha. The question is saying, what is the value of alpha if the average velocity for the entire duration is 0.8 v1? So shall I approach this question and you guys can help me out here? So what is for this one? So to find the average velocity for the entire duration, we average the total distance covered, right? So slowly and slowly this will come to rest, right? So the final position is going to be on the ground. So initial position is here. So we are interested in the net displacement, net path, net distance covered in the horizontal direction. Let's call it R net. R net divided by the time. Okay, so let's write down the expression for R net. So what is this R1, R2? Let's write them. So R1 is U0 square sine 2 theta divided by G. What is the next one? Same thing, but divided by alpha square as well. So 1 by alpha square U0 square sine 2 theta divided by G plus 1 by alpha to the power 4 U0 square 2 theta by G and so on and so forth. In other words, I can write R net as U0 square sine theta divided by G 1 plus 1 by alpha square plus 1 by alpha 4 and so on and so forth. Right, Peter? And what is this? Is a GP, geometric series, no? So what is the sum of the GP? You guys remember? So if you have a plus a square plus a3 and so on, right? Let's say there are n terms. Then what will this?
So to a to the power n minus 1 upon a minus 1.
Okay. So once again, what is it?
So a into a to the power n minus 1 upon a minus 1, considering a is greater than 1.
Okay. Is that right, Peter? Chavi? By the way, how do you quickly derive the expression for this one? So if S is this, then multiply S with A, so you get AS, and then you will get the A square plus A cube plus A to the power n plus 1. Right, Peter? Chavi? So if I
Yes, sir.
this from this one, what do you get? So a minus 1 times s, a square, a cube, those terms cancel out, and you get a to the power n plus 1 minus, right? So that's where Ruchika said it should be a into a to the power n minus 1 upon a minus 1. Now, what is a in our scenario? A is 1 by alpha square, right, Peter? And I should have taken that 1 plus. In that case, what will be? If I write 1 plus a square, then what will it be, Peter? Ruchika?
Sorry, sir, could you?
If the first term is 1, then how does it change?
So 1 into a to the power n minus 1 upon a minus 1. Yes.
Is that right? Sorry, we are digressing from physics and we're getting into math, but still it's kind of fun. Ruchika, just make sure that you're not lost track of the number of terms here, right? So if you subtract this one from this equation, what do you get? A minus 1 s equals to a to the power n plus 1 minus 1. Okay, so not a to the power n minus 1. I'm not sure. There are n plus 1 terms there. Anyway, so here also you will have a similar thing, but a is 1 by alpha square, and 1 by alpha square, alpha is greater than 1. Of course, that's why the speed, right? And these are infinite terms involved. So in the infinite terms, you will just be left with 1 upon a minus 1, right? So 1 upon 1 minus a, I should rather say. Minus a, that is, this all can be written as 1 upon 1 minus 1 upon alpha square. Now, if you write the time, the total time, the time of flight for the first time it hits back on the ground, so that is, what is the time of flight? You guys quickly recall, what is the time of flight, Peter?
So 2u sin theta by g.
2u sin theta by g. time it will be u0 sine theta by g, and you will have 1 by alpha there, and then you will have 1 by alpha square, and so on and so forth. So once again, you have 2u0 sine theta upon g, 1 plus 1. So you
Excuse me, sir.
yes, Peter.
Sir, is the answer for alpha is equal to 4?
Looks like it. So if I were to divide this R net by this one, should be 4. Let's just quickly check as well. Chavi beta, are you clear? It is 4. Okay. Chavi beta, clear now? Please.
Yes, sir.
Okay, let's move on to the next type of question on projectile motion. So here you might be asked to determine the radius of curvature at some point along the path. So this is an interesting concept. So let me just kind of blow it up, and then I'll try and explain it. I hope the diagram is pretty clear now, right? Okay. So let's understand the radius of curvature thing, right? So what does it mean? So let's say the velocity vector is in this direction at certain time. Okay. And let's say the force acting on the particles, by the way, we're talking about particle of mass m, and the velocity vector is in this direction, and the net force acting on the particle is in this direction, right? Now the force has, if I were to split the force into two components, the force has one component is this one, and the other component is this one. Correct? No? Now this component, I'm going to call it F parallel. I'm going to call this as F perpendicular. That means perpendicular to the velocity. Now F parallel will tend to increase the magnitude of the velocity. What will F perpendicular do? F perpendicular will tend to change the direction of V, right? Remember what we said when we were looking at the circular motion? So F perpendicular will act at that point, to change the direction. Okay? Yes, Peter? If this is V, then F perpendicular will cause this, right? And this change is dV, right? And this is V. Same logic, dV is V d theta, and then you can, same logic with that we had in circular motion. If the particle traces like this, right, it moves for a differential time. This is how it moves. So what we are interested in is at what rate, how quickly is the trajectory changing? That's what the radius of curvature essentially tells you. So if you were to follow the same logic, you will have F perpendicular is equals to m v square, which is V is this one. F perpendicular is mv square by r, which is the radius of curvature. So radius of curvature is mv square divided by component of force perpendicular to the velocity vector. Component of force perpendicular to the velocity vector. So let's see, if somebody says, give me the radius of curvature at the topmost point. Well, at the topmost point, mg, the whole of mg is acting perpendicular. So here I can say mg is equals to, v at the top is simply u cos theta squared divided by r. So the radius of curvature at the top, let me use small r because otherwise someone might think we are talking about the range. So this is the radius of curvature r. I'm going to write this as r, small r everywhere. So this is u cos theta squared divided by mg. Now if somebody says, hey, tell me the radius of curvature at this point, and the velocity is v dash at that point. So first of all, you need to quickly figure out what is this angle alpha that the velocity vector is making with the horizontal. Why is it needed? Because you need a component of the mg perpendicular to this. Okay, perpendicular to this. If this is alpha, then this is alpha. Okay, so you need mg cos alpha is equals to v dash square divided by the radius of curvature. So you would have to use this equation. Now, how do we find the angle alpha at that point? Well, if you can find the horizontal and the vertical component of the velocity, then tangent alpha is vy by vx. Okay. Once you have that, you can figure out what cos alpha is, and you can figure out the radius of curvature r using this equation. Is that clear? Yes, beta, is that clear?
Yes, sir.
I do need acknowledgement. So please do. It saves me energy. That's all, right? So just a simple.
So,
Yes, beta.
so mg cos alpha will give us a force, but v square by r is only giving us acceleration, right?
You are absolutely right. Write down m in there. So that's what it is. Okay. Everywhere else we've been writing m, but here in the yes, that's a simple error there. That's my mistake. Clear?
Huh, sir.
Newton's second law we are applying. F is equals to ma. Now let's go ahead and solve a problem or two. Yes, Peter, let's solve this one. Let me read through it. It says a body is projected at time t equals to 0 with a velocity 10 meters per second at an angle of 60 degrees with the horizontal. The radius of curvature of its trajectory at t is equals to 1 second is r. Neglecting air resistance and taking acceleration due to gravity as 10 meter per second square, what is the value of r? What is the value of r? While you guys are trying to solve it on your own, I'm going to scribble unless you guys tell me not to.
Sir, alpha is equals to 15 or I was
Alpha is equals to 15, okay?
so cos alpha will be root 3 plus 1 upon 2 root 2.
So how much is cos alpha?
So cos alpha will be root 3 plus 1 upon 2 root 2. So the 2 root 2 upon root 3 plus 1.
This is interesting. Something along this. Is this the answer? 2 minus root 3, not the most graceful unless I made some mistake here. Let's quickly check what this is. No, something is wrong. Oh, there's a 10 in there as well. Sorry. There's a 10 in there as well. This will be 2.7 or 2.8. 2.8. Not the most graceful here. Anyway, is this what you guys are getting as well? 2.8? 0.8 meters?
Yes, so 2.8 meters.
Anything, have you approached it slightly differently, or is this what you guys have done as well?
So the same method.
Okay. Chavi?
Sir, just 1 second. Last की calculation बची है.
Now, even though I kind of mentioned that we'll stop the class at 6:15, but I am overshooting myself just so that we can reach to our number 31. This is our fourth question type today. By the way, looks like it'll be Wednesday next week when we finish this chapter. Okay, Ruchika, Shavi?
Okay, sir.
Yes.
So now let's quickly, Chavi, you're settled? You got the answer, beta?
Yes, sir.
Okay, good. So now you might be given the equation of the trajectory and you might be asked to find the initial velocity, the maximum height, range, and whatnot. So it's walking back. Okay, walking backwards. So if you are given y is equals to ax plus bx square, so let's see how do we determine all these things here. So let's say you are given y is equals to ax plus bx square as being the equation of trajectory of the projectile, right? Then let's see if we can find the maximum height, right? At maximum height, the slope is zero. Slope is zero. So if you do dy by dx 0, in this case, that will be a plus 2bx. So your x will be minus a by 2b. So there, then maximum height, right? The maximum height h can be a into minus a by 2b plus b into square of this. That's your maximum height. Now, can you guys tell me how you will find the angle of projection? By the way, here we are assuming that the origin of the is the point of launch. Well, to find the angle of projection, again, you just need to, what is angle of projection? The slope of this equation at x equals to 0. So once again, what is dy by dx? A plus, that's why dy by dx is what? So this at x equals to 0, this is, so dy by dx at x equals to 0 is a. And if you equate to tangent theta, so theta, which is the angle of projection, is tangent inverse. Clear? How will you find
So,
yes, beta.
समझ ये वाला समझ नहीं आया.
Okay. So let's take a little bit slow. Beta, here you are given the equation of the projectile, or given the equation of the trajectory of the projectile. Let's say somebody tells you that when you threw a stone, if you were to x and y coordinates of the projectile, then the equation for the path is y is equals to bx square. Okay?
Yes, sir.
Okay. And then you might be asked to determine all the information about the journey. You might be asked to find angle of projection, the initial velocity, the maximum height, the range, all just from that equation. Correct, Beta?
Oh, yes, sir.
Right. So let's see if you have to find the maximum, what characterizes that point? Well, we know when the projectile is at the maximum height, the slope of the trajectory is 0, right? The slope is 0, dy by dx is 0. So if you take the derivative of the equation y is equals to ax plus bx that to 0, you will find out the x coordinate. You will find out this coordinate corresponding to this maximum height. Now, if you put this x coordinate, let's say x0, back into this equation, you will get y0. Correct, no? Yes, Peter? So you get your maximum. This is a nice trick, no? Yes, that's a pretty clever way of playing with the. If you have to find the angle theta and projection, then you know that the slope of this projectile of this at x equals to 0 must be to tangent theta at that theta being the angle of projection, right? So we found dy by dx, you put in x equals to 0, that'll give you the slope at the point of launch. And the slope of the trajectory is equals to the tangent theta, the angle of the theta being the angle of projection. Yes?
So,
Yes.
I solved one question similar to this. Usme what I did was we know the general equation for the projectile, right?
Right.
And then all you do is compare the values, like compare the coefficients. And you know the initial point x is 0, so anyways the x square part will become 0. So you get tan x is the coefficient of like x is tan theta anyway. So you can get the theta, right?
Yes, but what if somebody says the so by comparing, what will you get? You will get u cos theta, no? You can find out what is u cos theta. Correct, Amita? Right, Beta? You get u cos theta by comparing with the standard equation. That method is perfectly okay, by the way. Nothing wrong with it. Right? But
right, sir. Huh.
But I'm sure you're going to be a math student as well, no? Because this is it's quite beautiful to use the rudimentary approach of comparing. No? Look at the equation, understand what the slope and all this means. You get your answers right away, no?
Yes, sir.
Not that difficult. Similarly, for range, what would you do for the range? Well, for the range, y should be 0. So if you equate that y equals to 0, then x equals to 0. Well, we know y is 0 at the launch point, and at the landing point, it will be a plus bx equals to 0. That means x is equals to minus. This is your range then, minus a by b. If somebody says, tell me the velocity, so if you know the range, right, you know the angle theta, you can find out the initial velocity as well, no? Right? R is equals to range to u square sine 2 theta by g. So we have figured out theta, figured out R, you can figure out u from here. In any case, we are able to find all the things from this one. Let's see if a good question challenges us in the right way. But you're right, you can always compare it to the standard trajectory and try and figure out what's going on there. Let's look at this one. Y is equals to alpha x minus, let me just reduce the font size here. Let's go back to the, there we go. The trajectory of a projectile in a vertical plane is given as this, where alpha and beta are constants and x and y are respectively the horizontal and vertical distance of the projectile from the point of projection. The angle of projection and the maximum height attained HR respectively what? So now you can very well say, well, if I compare, then my tan theta is alpha, right, beta? And then you can say my beta is g by 2 u square cos square theta. So from there, you can try and find that. Or you can say for height, dy by dx is 0. So where is that? At x is equals to alpha by beta. If you put that alpha by beta in there, so your answer, your height would be alpha square by beta minus, the x is, where it's 0 is alpha by 2 beta. If you put that in there, you'll get alpha square by 2 beta minus alpha square by 4 beta. The answer is alpha square by 4 beta. Correct now? I don't know. So it's all about whatever you are comfortable with. Shall I do it again? So what I'm saying is, if you take this, y is equals to alpha x minus beta x square. So dy by dx, slope is 0 at the maximum height. So dy by dx equals to 0 implies x is equals to alpha by 2 beta. So if you put that back in there, you get your height as alpha square by 2 beta minus beta into alpha square by 4 beta square. This is alpha square by 4 beta. Correct na beta? Yes?
Yes.
And yes, tan alpha is, or tangent inverse alpha is the angle of projection. Again, you can take dy by dx or just by recognizing. Chavi, did this make sense, beta?
हाँ sir.
Otherwise, it'll be just lengthier, that's all.
सर एक बार आप h वाला पार्ट फिर से बता सकते हो?
So we said, at what point is my slope 0? At what x? Let's first find at what x, let's call it x0, is my slope 0. So first find out the expression for the slope. Slope's expression is, if you take the derivative, alpha into x, alpha is constant, x derivative will be 1, minus beta into derivative of x square is 2x. So now you equate this to 0 because here the slope is 0. dy by dx is 0 here at the topmost point. At no other point dy by dx is 0. So you cannot confuse this point. So this x0 at that point comes out to be alpha by 2 beta. Now we know the x coordinate of this maximum height. But given the equation of trajectory, if you know the x, you can find out. In this case, y will be your maximum height.
Okay, sir. हाँ, ठीक है.
ठीक है ना?
Sir, because I found the x and then I was like, ये तो answer में है नहीं. Yeah, okay, so I have to put it in the equation too. Forgot about
Right, right. Because you found the x, but they're interested in the height, in the y. Let's quickly take a look at the JEE Advanced question, see if there is anything recent in there. Wow, let's look at this one. Or let's do this. We'll pick up on this question first thing tomorrow. Tomorrow we don't have a class, right? No, we don't have a class tomorrow. We'll pick it up on Monday then. Or do you guys want to spend some time and solve it now? Why don't we go ahead and solve it? Okay, so take your time, Vita. Go ahead and solve this one. For the folks on YouTube, stop the transmission, or we're going to stop the lecture video here, and we'll carry on Monday. So just keep in mind that we'll be trying to release some helpful videos over the weekend. Maybe every weekend, but we'll try and push out some helpful videos for your preparation. And once again, I cannot stress enough, patiently work through the problems, right? The excitement and getting so the solving, the art of solving skill is just like any other skill. You have to just patiently go through it. Keep practicing. But practice smart. You should know which questions to practice. You just cannot practice 100 questions of the same type. That will not help, right? And that's why we are following this approach. So the sample class is to give you guys an idea of how powerful this approach can be. So for students who will manage to hear this part, I'll strongly recommend that you take this approach. We typically end up solving about 1,500 questions in 1 year, right? And that's a pretty good practice. But anyway, you guys take care. I'll see you on Monday, and I'll continue with the live class here. Take care. Bye-bye.